Welcome to all the students. Welcome to physics class. Today we are discussing about photoelectric effect. Okay, so we have seen the basics of photoelectric effect in the last class. Removal of electrons from the surface of a metal by supplying energy in the form of light and thereby removing the electrons. And namaste, thereby removing the electrons, and those electrons which are removed are called photoelectrons. Okay. Now, Leonard and Hallmark, they designed a beautiful setup to explain this photoelectric effect. So, shall we draw the diagram once again? So, it is your job to take the pen and paper and be ready with all the things. So, first of all, these emitted electrons, and electrons, if they have to be emitted, they should fall on a photosensitive material surface, metal. And a sufficient energetic electron, light has to be taken, and it should have an energy more than the work function, that you must know. And work function is the minimum energy required to remove the electron, that also you know. And when these photons fall on the surface, they supply energy to the electrons, electrons come out. And so you should have a surface which can emit electrons. Another anode which will collect the electrons. And all these electrons must be made to move here and there in an evacuated chamber. So basically you need an evacuated chamber, right? Like this. Hope you are also doing along with me. And you draw this, and if you don't draw this, then it's a waste. Better you watch some movie rather than this one. So it is a complete waste, right? If you watch a movie, it is a complete waste of time if the movie is not good. And if you watch this, you have to do this. You shouldn't keep on wasting the time simply by gazing at me, what I am doing and what I am saying. Just keep watching this diagram and keep doing it along with me, right? It's a cathode, and we are going to connect it to negative, but we can change the positive, that polarity of the battery also. Okay, so light from here, a suitable frequency should fall on this surface, and this is ultraviolet, and this is the source of light, and we call this as source of light, and this is ultraviolet light, this one, and this is quartz window, because you know ultraviolet is blocked by glass, so that should be quartz. This is quartz window, and this is evacuated chamber. It is made vacuum, evacuated chamber, right? And then what else? Okay, here should be an anode, okay, and here should be a commutator. You know this. Now we can do it fast because already we have seen it once. So 3 switches in a row, 3 connections in a row. Today I will take it in a gap so that you have enough space, and this cathode must be connected to the other end here, right? So this one here. What about the anode? So this is anode, and it should be jumped here like this. Hope you are also doing along with me. So this should be connected here. Then connect the last 2 terminals, cross connection, one here and another one jump here like this. Next, be ready with a battery and an arrangement to change the current. So a battery here, so I will take it in the same width. So a battery here, positive, negative, positive, negative. Okay, I will do it in a row. Positive, negative, positive, negative, positive, negative, like this, and up to this, and a resistance wire, long wire, where it is so long and it is wound, and you can connect it anywhere you want so that you can change the current. As you select more number of turns in the wire, the current decreases. Okay, that is ready, and now you have to connect these 2 terminals, one here and another one here, after making this getting ready. And you should have the current flowing through these wires, and you have to measure it, and you have to connect an ammeter, microammeter, micro in the 10 to the power minus 6 range. So this is the needle that is showing the current inside. This is microammeter. And if you want to note any voltage what you have supplied, it is needed later on, right? We are simply taking this circuit again and again in coming 2 hours also, right? This one here. What else? Finished? Over. This is commutator. And what else? This is plus, minus, and this is here minus, plus. And electrons emitted will be moving towards the anode. So like this, like this, like this, like this. So these are electrons. Okay. Very simple circuit. So theoretically, if you move, it will be very easy. But if you by heart, this will be a horrible circuit. You may not be knowing where to connect. And you will connect it anywhere else and you will lose the mark. So now the Hallmark-Lenard's experimental setup over. Now, initially, which switches you are going to close? Of course, you are not going to write it in the exam, and that means you are not going to show it. Let me close these two switches, this one and this one. I'll show it in a different color. Hope you have finished, right? You have finished the drawing. So connect the first two gaps of the commutator. Commutator is a device which will change the direction of current in the circuit. Simply keep the keys in the two-way key, then the current gets reversed automatically. Okay, you have selected this end now, right? Now from the positive, here, if you start from cathode, from the cathode you have to connect here. Of course, if you come down, no, you can move here. If you come here, no movement, open at both ends. So you have to come here, come like this, like this, like this, like this, negative. So from where did we start? Cathode, right? Cathode to this one, like this. Cathode is negative. What about anode? It should be positive. Like this, here, coming like this, positive. Cathode is negative, anode is positive. As soon as light of suitable frequency and energy, of course, falls on the surface, E is equal to h nu is equal to hc by lambda. Falls on the surface. Electrons are emitted from the surface. Electrons, as soon as they come out, they see the outside world. Oh, it is vacuum. Nobody is there to oppose us, so we can move. And there is somebody who is greeting us. Come on here, and he is welcoming. That is a positive electrode, because electrons are negatively charged. This positive potential will attract them, so it attracts it. So electrons come, complete the path, and you get a current in the that ammeter, microammeter. Now Hallmark and Lenard, they found that the current went on increasing as the intensity of light is increased. They took the same source, they went on increasing the brightness. What do you mean by that? Nu is not changed. Lambda is not changed. Keeping nu and keeping same energy of photon. That means I am not changing the source. Same energy of photon means not changing the source. Not changing source. Same source, but brightness more. You can supply more and more voltage to this bulb, and you can make it brighter and brighter. For example, red light, same red light, more brighter, less brighter, medium brighter. So when the intensity is changed, not changing the source, not changing nu and C, same nu and same C. So these two, not C, lambda, same lambda and same nu. So keeping them same, keeping the same energy per photon, but number of photons are increased. Of course, this is the later explanation I can give. So when intensity is increased, photoelectric current increases. Photoelectric current increases. This is one conclusion they got. First one, I say. Maybe it may not be the first one, but I name it as first one because it came to me and I am explaining it. So when the intensity of the incident light is increased, photoelectric current went on increasing. And how? It was linear, and they did it for different values. When the intensity was so much, they calculated what is the current. They doubled the intensity. The bulb was made double brighter, and the photoelectric current was found to be more. That means more electrons are emitted, correct? And again the source is made 3 times more brighter, 3 times more current they have got, more electrons were emitted. So if you draw a graph of photoelectric current, this current versus intensity, that means brightness of the source, they got a graph like this. A graph of photoelectric current versus intensity was obtained like this. Okay, that's right. First conclusion. Okay, second one, shall I write it here? I want enough board today. Second one, can you see this? Right? I can write it here and you can see this. Yes. Now, they started doing the experiment with frequency. They changed frequency. If you want to change the frequency, you have to change the source itself. Because one source will have one particular frequency. Brightness you can change with the same frequency. But if you want to change the frequency itself, you have to take the light from red color to blue color to yellow color, green color, so like that. You have to change the frequency and wavelength. Okay, when frequency of incident light is changed, say you start from the lowest frequency, some available frequency. Photoelectrons were not emitted and no photoelectric current was found. Why? Very simple reason. The energy of those photons may not be enough to remove the electrons, isn't it? Increase the frequency. No photoelectrons are found. So I will simply give the examples like this. I will take a source of ultraviolet which has a frequency nu1. Even in ultraviolet I can get different frequencies, right? Even in red I can have different red. Even in green, in your nature you see different green. So there are different frequency greens. There are different frequency ultraviolet lights. Nu1, no photoelectrons are emitted. Nu2, I will increase it. No photoelectrons are emitted. Nu3, I see some photoelectrons are emitted. I see some current in the circuit. Okay, so photoelectrons are emitted, say. And this Nu3, I will take it as Nu0 and I call it as threshold frequency. What do you mean by threshold frequency? The minimum frequency above which photoelectric emission can take place. Sir, if I increase the frequency further, for example, I'll take numerical example itself. Sir, when I took 2 into 10 to the power 14 Hertz frequency is measured in Hertz. No photoelectrons are emitted. 2.1 into 10 to the power 14 Hertz. No photoelectrons are emitted. Because I don't get any current, I can check it. 2.2 into 10 to the power 14 Hertz. Yes sir, I get photoelectric current and there are photoelectrons emitted. That means photoelectric emission started from 2.2. What about 2.3 into 10 to the power 14 Hertz? Yes, there are photoelectrons emitted, because if 2.2 frequency, 2.2 into 10 to the power 14 Hertz frequency can emit electrons, means definitely this can emit, because E is equal to h nu, E is directly proportional to nu. More the nu, more is the frequency, energy. More is the nu, more the frequency, more the energy. So more and more energetic. What about 2.4 into 10 to the power 14 Hertz? Yes, photoelectrons are emitted. That means out of all the photoelectric emission possible frequencies, this is the minimum value, correct? Any value greater than this is fair, good enough to remove the electrons. Any value less than this is not able to remove the electrons. So the minimum value of frequency above which photoelectrons are emitted, or the minimum value of frequency which can remove the photoelectrons, just remove the photoelectrons, is called threshold frequency. So above the threshold frequency, photoelectrons are emitted, but below the threshold frequency, photoelectrons are not emitted. So shall I call this as nu naught? Nu naught is the minimum frequency above which photoelectrons are emitted, and that is called threshold frequency. So if you are asked to define what is threshold frequency, the minimum value of incident frequency above which photoelectric emission is possible, or photoelectrons are emitted, below which no photoelectrons are emitted, is called threshold frequency. Threshold means always the junction value. Below that you don't have, above that you have, or vice versa, whatever it is true. But here, below the threshold frequency, no photoelectrons are emitted. Just at the threshold frequency, photoelectrons are emitted. Above the threshold frequency, photoelectrons are emitted. And if you go on increasing the frequency further, but there is no change in the photoelectric current, once you reach the threshold frequency, suddenly you get current. But if you increase the frequency from threshold value, say for example 2.2 in 10 to the power 14 Hertz, there is no change in current, but there is current, no change in the current. That means for every material, there is a minimum frequency below which no photoelectrons are emitted, above which photoelectrons are emitted. and that frequency is called threshold frequency. Now, does threshold frequency give any idea? Yes. It gives the idea that there is a minimum energy required to remove the electrons. And what do you call that minimum energy? As work function. Remember, work function is the minimum energy required to remove the electrons from the surface of a metal, and the symbol for work function is phi. Now, can you get phi from this nu naught? If nu naught is the minimum frequency required to remove the electrons, what is the energy of that photon which is just removing the electrons? That is h nu naught, because energy is h nu, correct? What is that h nu naught? That should be the work function. One formula, isn't it? So if nu naught can just remove the electrons, any frequency less than nu naught cannot, more than nu naught okay, then that nu naught must be having an energy which is equal to just remove the electron, which is called work function. So how to convert that nu naught into energy? H nu naught, that is work function. So below the threshold frequency, photoelectrons are not emitted. Above the threshold frequency, photoelectrons are emitted. But if you go on increasing the frequency from threshold, photoelectric current doesn't change. Okay? Right. Now, shall I remove anything here? Yeah, keeping, yes. This is needed. First point is needed. That is increasing the brightness intensity here, so increases the photoelectric current. That means photoelectric current depends on, that means how much current is produced by the these emitted electrons. Photoelectric current depends on intensity of the incident light, brightness of the incident light. It does not depend on current, does not depend on frequency, isn't it? Right? So this is their conclusion. But Einstein was able to explain, give clear explanation on all these things. That we will see later. So, but you need a minimum frequency for the electrons to come out. But once they come out, there is enough photoelectric current. But you can't change it by increasing the frequency. There is a requirement of minimum frequency for removal of electrons. There is a requirement of minimum frequency for photoelectric current. But beyond that threshold frequency, there are photoelectrons coming, but they don't increase the current. So photoelectric current depends on intensity and does not depend on frequency. It is independent of frequency of incident radiation, frequency of incident light. Okay, now they went for one more experiment. Okay, electrons have come out and these electrons have started moving towards anode, and now I want to see whether these emitted electrons have energy or not. It is simply like, I can give you the answer now only. How did Einstein explain it? It is simply like you moving or you are going to your grandma's or somebody's house. You need bus fare. You will ask your father, give me the bus fare, I want to go to grandma's house. Okay. The bus fare is say some 80 rupees. Then there are more chances. Your father may give just 80 rupees and your father may give 100 rupees. Your father may give 200 rupees, 300 rupees and so on. But if your father gives less than 80 rupees, you will never go to grandma's house because that money is not enough to reach your grandma's house. Correct? And sir, if my father gives me 60 rupees, can't I move? Just out of 60 rupees, how much I can travel by bus? I will travel and later I will walk. Nobody will do that. If you are given only 80 or more than 80, you will fix the traveling. Otherwise, if you are given 50, 60, 40, anything, rejected. Because that is not enough, because you are not ready to walk even a smaller distance. You want to go by bus only, right? And of course, there small walking you can do that. But kilometers wise you can't walk. So 80 rupees is the minimum requirement to reach your grandma's house. That is work function. Once you are given 80 rupees, you can move. Suppose you are given 100 rupees. What will you do? Will you return 20 rupees to your father? No. You will spend 80 rupees to your traveling as bus ticket, and remaining 20 rupees you will enjoy. Either to purchase anything or to eat something, anything, right? Suppose you are given 120 rupees, you will spare only 80 rupees for traveling and you will enjoy with 40 rupees. And if you are given 150 rupees or 120 rupees or 100 rupees, nobody will give more money to the conductor saying that my father has given more money to me, so please keep 20 rupees with you, so you are lucky, take it away. Nobody will give him. The traveler will give only 80 rupees to the conductor. That is a constant. That means work function is a constant for a material. The traveling fare is a constant irrespective of the money that you have in your pocket. If you have 500 rupees, you don't pay 100 rupees as a bus ticket. If you have 50 rupees, you don't pay 50 rupees as a bus fare. You will pay only 80 rupees. It does not depend on how much money you have in your pocket. So work function depends on the material. The traveling expense depends on the distance through which you travel, the house to which where you have to travel. It doesn't depend on the incident frequency, right? So if you have more and more money, then what the money you will remain with will become more. If you have 200 rupees in your pocket, definitely you will remain with 120 rupees. If you have only 100 rupees in your pocket, you will remain with only 20 rupees after the journey. If you have 150 rupees in your pocket, you will remain with 70 rupees in your pocket. So the remaining money goes on increasing. Now the thing happening here is same. Electrons are simply sitting inside the material. They are waiting for somebody to supply energy. They are waiting whether the energy comes in the form of heat, light or so. They expect that the energy comes in the form of light. Photons come and supply energy to them and they can jump and come out. But how much energy they need to come out, that is called work function, that is constant. So somebody will supply energy in the form of ultraviolet radiations, and photons of ultraviolet will fall on them, and they are sitting inside. They absorb the energy from the ultraviolet photons, they come out. Now they first check whether that energy is enough or not. If the energy is enough, if the frequency is enough, 2.2 into 10 to the power 14 hours, if the frequency is threshold frequency, that is just enough to come out. They will come out and they will simply stand like this. Why? Reason is very simple. What the energy we have supplied is just threshold frequency energy, that is h nu naught. That can just remove the electron, and the emitted electron will have no paisa in its pocket. Nothing remaining. You have only 80 rupees given by your father, and you have only 80 rupees for traveling. You don't have anything left in your pocket once you get out of the bus in your grandma's house. So if the supplied energy is equal to the work function, emitted electrons will not have any energy left with at all. Suppose the supplied energy is more and more and more, 2.3 into 10 to the power 14, 2.4 into 10 to the power 14, 2.5, 3 into 10 to the power 14, so on. Then what the electrons with that remaining energy do? That is very interesting. Suppose the supplied energy, required energy is 10 joules and you are supplying 15 joules. What 5 joules will happen? What happens to 5 joules? Electrons use that energy as kinetic energy. Very simple. They use the enough amount of energy to come out, not more, only that much required to come out, what you call work function. Remaining energy is used as kinetic energy. They start moving. That's why they move. And moreover, this positive anode will attract them. That is different. But another thing is they start moving here and there. And usually electrons will have kinetic energy just opposite to the way in which light is falling. When the light falls from here, electrons are not emitted from back side. They are emitted from front side only. Electrons come out and they start moving. With what kinetic energy? That depends on incident energy. This is what Einstein studied. He gave an equation, very simple equation you see. Suppose you are given 150 rupees, you will spend 80 rupees for traveling, 70 rupees will remain. Equation, how is the equation? 150 is equal to 80 plus 70. That's all. If you supply some amount of energy, among that, a little amount of energy is used to remove the electrons from the surface of the metal, and remaining energy is used as kinetic energy. That means, as you supply more and more frequency, as you use a source of more and more frequency, remember, I am not increasing the brightness, I am increasing only frequency. Don't get confused. Brightness means I am choosing the same frequency, increasing the number of photons. That's all. When I use more and more frequency, and the energy of the incoming light will go on increasing, energy of the emitted electrons go on increasing. So incident frequency increase, will increase the kinetic energy of electrons, not the current. Sir, why don't current increase? What do you mean by current? Current is the rate of flow of charges. How many charges flow per second? That is current. If current has to increase, you should increase the number of photons. Sir, how to increase the number of photons? Can't I increase the frequency? No. If you are increasing the frequency means you are emitting the same number of photons but more energetic photons. Because increasing the frequency, 100 photons means 100 photons only, but each photon will have more energy. That's all. That will not increase current. For current, I want more photons, not more energetic photon, more number of photons. So, when I increase the frequency, of course, if you are getting confused, just keep on following me. At the end, you will understand. So, if you increase the frequency of incident radiation, kinetic energy of the emitted electrons will increase, because only that much which is used for removing the electrons, that is used as work function, and remaining energy will be kinetic energy. So if supply is more, definitely kinetic energy is more, right? Now the question is how to measure this kinetic energy. Of course, if you increase the brightness here, current will increase. That can be noted down. How? Because you can see the current. More the brightness, more the intensity of light, more the current. You have drawn it, right? More the current, more the intensity of light, more will be the current. A graph flowing from 0. When there is no intensity, no brightness means, what is the meaning of no brightness? No light at all. Switch off the light. What is the brightness? 0. No brightness means no photons falling, no photoelectric current, no photoelectric effect at all. So no current. But when you increase the frequency, kinetic energy is increasing. How to study this? That part we will take care of today. How do you say that kinetic energy increases? So to check the kinetic energy of electrons, Hallwork and Leonard did one beautiful experiment, right? We will spend 3 sessions in this experiment so that in the examination you can beautifully write it. We have enough time, and some people say that so many chapters are over in some college there and this. Don't worry, we have enough amount of time. We can study properly and we can move through, right? So, because if you understand the theory properly, then remembering it for a long time is not a big task. Okay, right. Where we are now? Yes. I want to check the kinetic energy of electrons. Very simple procedure. What you have to do? Sir, I want to see whether that car is moving with more kinetic energy, whether this bicycle is moving with more kinetic energy. What can I do, sir? Simple procedure. Stand in front of car once, stand in front of bike once. You will understand which is having more kinetic energy. Why? Because if the car comes with a speed and hits to you, what damages it will do on you and what pain you will get. And when the bicycle comes and hits to you, what damages it will do on you and what pain you will get. That will be directly proportional to the kinetic energy of the car, kinetic energy of the that bicycle. Very simple. That means try to stop them. You will come to know how much energetic they are, isn't it? For example, if this is a hill, say in the rainy season, some stones are just tumbling down the hill like this. Different sized stones. Now, if you want to stop the stones, what you have to do? You have to, some people are standing here. Imagine that we are very strong, we can stop those stones, and they have to like this and they have to stop it. Right? You need more energy to stop heavier stones because they will having more kinetic energy. What about smaller stones? Less energy is enough. Now, if you have a person who can stop smaller stones, of course he can't stop heavier stones because they will have more energy. Now you have to select a person who can stop the highest energetic stone. Can't he stop less energetic stones? Definitely he can stop, isn't it? So a person who can stop the most energetic stone can also stop the less energetic stones. So on an average, if you can calculate the energy of the most energetic stone, that will give you the highest energy among all the stones, and now you can stop any stone which is having lesser energy. Same thing you have to make it here. Now what you have to do is, you have to stop these electrons. Electrons are coming with kinetic energy, you just stop it. If you want to know how the cricket ball is hit, with what energy, stop it. You will come to know how much faster it was moving, how much harder it hits your hands. So is the kinetic energy. Similarly, if you want to stop these electrons, who will stop it now? Shall we stand here and stop all the electrons like this? Not possible. Who will stop it? Battery. Battery will do it. What the battery have to do is, you have to reverse the battery. When you reverse the battery, you can stop the electrons which are moving, right? So how to do this? How to stop these energetic electrons? Battery can do that. How the battery can do it? Very simple. We have the help of the commutator. You can reverse the commutator. How to reverse the commutator, sir? Simply throw the switch to the other opposite corners. That's enough. Simply throw these switches here. So one switch here, another switch here, and you can throw it here. Connect these two. Enough. That is the beauty of commutator. Now what has happened? Last time this was negative, this was positive, correct? Now see them. Negative coming like this, like this, like this, like this. This is positive now. Positive. Did you get that? Cathode coming like this, like this, like this, coming over here. Positive. What about this one? Anode. Anode coming over like this here, like this here, like this here, like this. Negative. This is negative. Can you follow this? Anode coming over here. Just we have changed this switch. Last time it was here. So now this is here and you have to go here, 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 here. Negative. Now anode is negative and cathode is positive. We have reversed the potential. Now we have to, so what is our aim now? Our aim is to stop the electrons and find out how much energetic they are. And in the first chapter of the second PU, you get a definition. And for those who have not, this is not over, just see that definition. We always, I will explain about 2 minutes for that. I will take some few minutes and then you will understand. What do you mean by battery voltage, potential difference of a battery? We say, sir, I have purchased a battery of 5 volt. I have purchased a cylindrical battery of 1.5 volt. What do you mean by potential difference of a battery? See, battery has to do the work in sending the charges. Suppose you connect a battery to a bulb glows, right? And if you have a switch and all, like this. As soon as the switch is closed, the bulb glows. Why? Because electrons have started moving from negative of the battery to the positive. So electrons move like this and we call it as current like this. Current is the rate of flow of charges. And battery will do the work in sending these electrons. Electrons are already in the conducting wires and the tungsten filament and all. Battery will do the work in pushing them. Work done by the battery in sending the charges. So potential difference of any battery is the work done by the battery in sending the charges. Work per charge is the potential difference. Joule per coulomb. Charge is coulomb. That is the definition of potential difference. So we must have a small deviation here. And those who have completed this chapter, just recall it. Those who have not, just follow this. This is enough. So potential difference of any battery or potential difference between any 2 points is the work done by the battery in sending the charges from one point to another. Work done by the battery in sending the charges. Work per unit charge. That is potential difference. What is the work done then? Work done is equal to potential difference into charge. Charge is the Q, work is W. If you take it like this, this is the famous formula that you have to do. Charge into potential difference. For example, if a battery sends 1 electron from one end to the other end, if the potential difference of the battery is 10 volt, what is the work done, sir? If the potential difference of the battery is 10 volt and if it sends 1 electron, charge of 1 electron is 1.6 into 10 to the power minus 19 coulombs, then the work done is 16 into 10 to the power minus 19 joules. This is the work done by the cell. So every battery will have its own potential difference, that means its own ability to send the charges. Work done by it to send the charges. So every battery will do the work in sending the charges. As long as this battery is connected, this bulb glows because battery will keep on moving the charges. And as soon as the battery is disconnected, this doesn't glow because the electron flow stops. Now, coming back over here. Now this is oppositely connected. Electrons have been removed from the cathode, but cathode has become positive. Those electrons are attracted towards the cathode. but still they may have enough amount of energy, because sufficiently high kinetic energy, sufficiently high energetic beam may be incident on the surface, and these electrons may be coming out and they will be going towards anode. But anode is given negative potential, but still these electrons can move and move towards the anode. So will the current become zero? That's my question now. Will the current become zero? No, because even though this is negative, that negative voltage given by this may not be enough to stop these electrons. Even if you have a person here, the strength of that person may not be enough to stop these stones, isn't it? So what we have to do, sir? Increase this. If you put an arrow mark over a battery in electronics, it does mean that you can change the value of the battery. You can change it from 1 volt, 2 volt, 3 volt, 4 volt like this. Now the question is, I will do the experiment like this. Hallmark and Lennard did the experiment like this. They chose a sufficiently strong energetic beam of light. Father has given you enough amount of money, 150, right? 150 rupees. For traveling you need 80 rupees, but your father has given 150. So how much you need, how much you have as kinetic energy? 70. You have enough energy, so you can emit, you get come out of the cathode, you start moving. Now I will start increasing this from 0 volt. 0 volt means this is 0, this is 0. Nothing is given. Battery is stopped, switched off. Electrons happily reach here. Nobody is opposing. And increase this, increase the negative potential. This becomes negative. You know, this is reversed, right? This is given here. Of course, in the examination, you are not going to show any connection here. You are just, valuer will come to know that you have changed it. Okay, this is given negative now. Increase it. As this is given negative, electrons get surprised. Somebody who is welcoming us earlier, now they are just opposing us. Don't come here, go away, because you don't come here, I am negative potential. Electrons, you repel me. So electrons start repelling. But the energy of the electrons may be very sufficient to overcome this repelling force, and they may reach here, because we have supplied enough energetic ray here, photons here, and that energy may be sufficient to remove the electrons, as well as electrons will have sufficient energy remaining with them. So with that remaining energy, they will be moving with high kinetic energy, and they may be reaching here. They won't be carrying for this negative. So what we will do, we will increase this 0, minus 1 volt, minus 2 volt we will do. Minus 2 means it is already minus. It is connected in such a way that we get minus, because it was not in the other way. So minus 2 volt. Now out of the coming electrons, some electrons may find it difficult to reach here, because their energy may not be enough to reach the anode. But some electrons may be sufficiently energetic, and they may reach this anode. You may get a small doubt here. I will raise that doubt later and I will solve it. So some electrons may reach here, some electrons may not reach here. What happens to the photoelectric current? Goes on decreasing, right? It goes on decreasing and decreasing and decreasing. Now as I go to minus 3 volt, few more electrons cannot reach here, but in among the all electrons, some electrons may be still energetic, and they may reach here and they may complete the path, and they may produce current, even though this is negative potential, even for minus 3 volt. Say when I make it minus 4 volt, current becomes 0. What do you mean by that? Does it mean that photoelectric effect is not occurring? No, photoelectric effect is beautifully occurring. Light is falling on this, electrons are emitted, but electrons are not given any welcome from this, because that is given sufficient negative potential, and that negative potential is sufficient enough to stop the final electron also. And this person is strong enough to stop the strongest stone itself, strongest stone in the sense, most energetic stone itself, and this person can stop any energetic stone, because even the less energetic stones may be stopped by him, because he was able to stop the most energetic stone itself. This potential, reverse potential of this anode should be given positive actually, but anode is given negative. The reverse potential of the anode can stop all the photoelectrons. Photoelectric current becomes 0. Photoelectric current becomes 0 not because that the photoelectrons are not emitted, they are emitted, they are stopped by the reverse potential of the anode. Now, how much energy this anode is spending in stopping the electrons? Is it not the kinetic energy of the photoelectrons? Because those electrons are stopped. In the beginning itself I was saying, if you want to know what is the kinetic energy of a car, go and stand in front of the car and try to stop it. What energy you spend in stopping it is the energy of the car. If you haven't stopped it, means you have not given enough energy to stop it. So if you have stopped it, means you have given enough energy to stop it. What energy you have lost is the energy of the car. Similarly, minus 4 volt can stop all the electrons. That means this minus 4 volt is the energy in some or other way, it is not exactly energy, is the energy spent by this anode to stop or energy spent by the battery to stop the electrons. Now how to convert this 4 volt into energy which is equal to kinetic energy of the electrons? Very simple. Come back to this. Work done is equal to charge into potential difference. Now in this our experiment, who did work to stop the electrons? Is it not the battery? Because we have reversed battery and made these electrons to stop. We have opposed the electrons, repelled the electrons by giving negative potential. Negative potential is given by the battery. So how much work is done by the battery in stopping the electron? Work done by the battery is equal to charge into potential difference, right? Charge into potential difference. Work done by the battery is charge of the electron, 1.602 into 10 to the power minus 19. Potential difference, that is this one. I will call this as V naught. What is V naught? V naught is called stopping potential. One more definition. Don't worry, I will tell you how to put all these things as an answer in the exam. I haven't put what type of questions will be asked. Sir, we are discussing from 2 hours, 2 sessions, the same thing. What about the answers that we are going to write? I will tell you what the answers you will have to write, what are the definitions. But listen to the teaching and listen to the idea behind this. Then we will put the questions and answers. Okay? Okay. So, work done is equal to charge into potential difference. Work done is the charge of the electron into potential difference is V naught, and V naught is called stopping potential. Sir, what about minus 5 volt? For minus 5 volt, will you get photoelectric current? Never, because minus 4 volt itself can stop all the electrons. Means, what about minus 5 volt? It can also stop all the electrons. If this man can stop all the heaviest and most energetic stone, means if a person stronger than him can stop anyway, right? So this is the minimum potential required. The minimum reverse potential required. Can 5 volt stop it? Yes. 6 volt? Yes. Out of all these, this is the minimum which is required. Which can stop? This cannot stop, right? So the minimum reverse potential of the anode which can stop all the photoelectrons reaching the anode, that is called stopping potential. Now what you can calculate from stopping potential? Stopping potential, you can calculate kinetic energy of the electrons, and this is work done by the battery, that is equal to kinetic energy of the electrons, right? Well, this is work done by battery, it is not work function, don't confuse, it is work done by the battery in stopping the electrons, so it should be kinetic energy of the electrons. Work done by you in stopping your stopping a car, it is the kinetic energy of the car. So kinetic energy of photoelectrons is given by EV naught, where V naught is the stopping potential. Stopping potential is the minimum reverse potential of the anode at which all the photoelectrons are stopped reaching the anode. Even though the photoelectrons are emitted, this is not given positive potential. If it is given positive potential, electrons happily reach here. This is given a reverse potential such that all the electrons are stopped reaching the anode, and that is stopping potential. And from stopping potential, you can measure kinetic energy of photoelectrons, that is EV naught. Don't forget these formulas, only small formulas. So EV naught is the kinetic energy of photoelectrons. Now you can measure kinetic energy of photoelectrons using this formula, EV naught. Now my question is now coming to the most important part, if you have followed this. So we have two things now. Threshold frequency. What do you mean by threshold frequency? It is the minimum frequency required for the photoelectric emission to happen, right? here. Where is threshold frequency? We have removed it. So h nu naught, right? So if you incident a frequency which is less than required one, no electrons are emitted. So there is a minimum frequency that I was discussing, 2.2 into 10 to the power 14 hertz. There is a minimum frequency above which photoelectric emission can take place. So there is a minimum frequency where I can write it. Yes, I will write it here. There is a minimum frequency called nu naught above which photoelectric function can take place. So work function is equal to h nu naught, right? What about stopping potential? The minimum reverse potential of the anode, which can stop all the photoelectrons reaching the anode and make the photoelectric current zero. Remember, at this time photoelectric emission is happening, but we are stopping all the electrons by using a reverse potential. So what does stopping potential give? Kinetic energy of photoelectrons. Now stopping potential depends on what? That is the question. If you have understood, you can understand, you can go on thinking. Stopping potential depends on what? Does it depend on frequency of incident radiation? For example, I will give that live example. You will be left with the 70 rupees if your father gives you 150 rupees, because travelling charge is 80 rupees. Father gives you 150, you will give 80 rupees to bus and 70 rupees will remain. Suppose your father gives 200 rupees, then you will be left with 120 rupees. So remaining money goes on increasing. That is kinetic energy. Now, if you are having more and more remaining money, you will be more and more happy. Imagine that you are running to your grandma's house more and more faster. Suppose your father gives only 80 rupees to you, you will give 80 rupees to the conductor and you will go to the grandma's house with the very pale face, right? And if you are given 150 rupees, you will be having 80 rupees and you will be going like this. And if you are given 200 rupees, you will have 120 rupees in your pocket, you are running, and you are given 300 rupees, more money remaining, running and running. Now how will your grandma come to know that your kinetic energy is more and more? Your grandma has to stop you by the time you enter into your house, because you will have to enter the house with all sanitizer and cleaning yourself. So grandma will spend energy in stopping you. That will tell you how does the kinetic energy is. Now the energy your grandma has to spend, the energy that the battery has to spend to stop you, to stop the electrons, directly proportional to the money that your father gives, isn't it? More the money that your father gives, more the money you will have remaining, and the more energy your grandma has to have to stop you, because you will be running with more and more happiness. Similarly here, similar thing happening here. So shall I put on some light, because it's raining heavily outside? I'll put on one light. Okay, you can't see otherwise. Yeah, can you see now? Little bit? Yes. If not, I will conclude now. So otherwise, yeah, you can see a little bit now, right? Yeah. Now, so with regard to this electrons coming, more the frequency of incident light you have, more than threshold, of course, it should be more than threshold, otherwise electrons won't come out. More the frequency you select, only that fixed energy is used to remove the electrons. Remaining energy is used as kinetic energy, and you need more stopping potential. Correct? That means stopping potential depends on frequency of incident radiation. Stopping potential depends on frequency of incident radiation. Incident radiation, correct? Suppose for example, minus 4 volt can stop electrons now. Now I slowly increase the frequency. Without telling anybody, I will increase the frequency. Now the incoming electrons will have more and more energy. If somebody start putting more and more energetic stones, then you need a person with more and more energy to stop it. So more frequency and light when it is incident, energy of the incident light is more, remaining energy is also more. After removing the work function, remaining energy is more. That means kinetic energy of the photoelectrons is more. And if the kinetic energy is more, more energy to stop it, more potential to stop it. So kinetic energy depends on frequency, so stopping potential depends on frequency. So small glitches. Be ready in the next class, be ready with all these definitions. Work function. You need not worry whether you have understood it completely or not. By the end of the next class, you must be ready with so many graphs. By the end of next 2 classes, it must be very clear. When I complete the next 2 sessions, you must be clear with all these things. Then if you are not clear, of course, you ask me questions, I will clarify it. But till that, don't be in a worry, no issues, because you have not been with all the data. I have been teaching you again and again this one. So now, you must be ready with this experiment. And how does positive negative change? And what happens here? Threshold frequency and work function and this stopping potential. Increasing intensity increases current. Increasing frequency increases kinetic energy. So I can have a relation, right? Frequency increases kinetic energy, right? Increases stopping potential. Increasing intensity. For this light, you can change 2 things. You can change frequency as well as brightness. When you increase brightness, photoelectric current increases, right? This increases. But when you increase frequency, photoelectric current doesn't change. That we were studying about. We will study that in detail also. When you get the Einstein's explanation, everything will be clear. Why it happens so? Einstein gave a beautiful explanation and you can understand why it is so. Okay, increasing intensity increases the current, and this is not possible. Increasing frequency, no increasing in current. Increasing kinetic energy, no increasing in intensity. Crosswise, it is not possible. So for the time being, I'll stop the explanations, right? We will meet in the next class with few more explanations, same diagram, same explanation, with a few more ideas. So I think by the end of the next class, I will come to the edge of this. And in the very next class I will finish it. Finish this part only, experimental observation. Then we will just see what type of questions you will have to answer in the exam, how to write the answers. Then it becomes very clear. You have to write only this much you have to explain, definitions, graphs and all. One graph already we have seen, intensity versus photoelectric current, right? More the intensity, more current. So with this I am stopping this class. So continue to read the book. Don't be lazy. Be in touch with the topic, and you will get some assignments later on. We are preparing it and we are trying to engage you little bit, not completely in the whole day. So please respond to it, because if you are very alert now, then the later days will be happy days. Otherwise, once the classes start, you will have plenty of work. So to avoid it now, please work now. Don't neglect all these things. Don't say that we don't get the range and this and that. You will have so many reasons to escape, but you are escaping from your own life. Remember, you are escaping from your own achievement. So don't do that. Hope you will do well. Thanks for watching my class. We will see you in the next class. Thank you.